Today we will be doing Surds. Now this chapter has been neglected, like how you see the file name, neglected. Okay, and I have gotten every single question of Surds Cambridge have officially released. Okay, and put them into this one file. Now this is the only outlier here, using a specimen paper. Yes, I need to delete this because this then makes the file have a total of 100 questions. That means there will be 35 repeating decimal questions and a total of 65 Surds questions. Yes, I know. So let's not do specimen paper. Let's come over here and do the remaining. Now let's first define a surd. A surd is where a square root has a number such that it cannot be simplified any further. Okay, example, we have square root of 2, square root of 5, square root of 7, square root of 11. Yes, these are all primes. Square root of 3, blah blah blah, square root of 6 even. Okay, all these are surds. What does a surd, what if a surd has in this number, or a this number, or a this number, or a this number? These all numbers are examples of perfect squares. Perfect squares. What is a perfect square? It is when you multiply two positive integers, make a new number. That number is a perfect square. Okay, whose root gives us a integer. Okay. However, a surd does not evaluate to a integer. No, it's not a integer. It is a irrational, non-repeating, non-terminating. Okay, example, we have square root of 2. Square root of 2, if you compute it in a calculator, which we only use a calculator to do it, you get like 1.414213562 and so on. If you are my phone's calculator can compute it to any accuracy that I wanted to. Obviously, I do not need 1,000 digits or even further than that, because it is non-repeating, non-terminating. There is no repetition in a surd. Okay, so it is the irrational. Okay, now how do we work with these surds? Is that we treat them as different variables. We treat them as, like a variable. Example, this. We do not simplify this. We just keep it as root 2 plus 1. Okay. And we, keep it as this for throughout. See, you cannot simplify this unless you have a calculator. Okay. Now, what operations can you do with surds? We see we are adding them, we are subtracting them, we are multiplying them, and we are also dividing by them. Okay, so what on earth can you do with them? Well, addition is somewhat of a different, addition and subtraction. And this is where you need to use your indices rules. If you guys have done indices, you may know that this rule, that if we have two numbers who are multiplying with the same power, it is the same as the product of those two numbers to the nth power. We use this rule extensively to our advantage to simplify these surds. And prime factorization, of course. How? Let's look at a few examples. Okay. So example here, okay, I'll just do like 10, and then you guys can follow through with the remaining worksheet, with the remaining 60 questions. Square root of 300. What is this? 300 is the same as 3 times 10 squared. 10 squared formula is 2 squared times 5 squared. You can use prime factorization to find that out. Okay, I'm not gonna do it, sorry. So we got this, and we add it by square root of 48, which is 2 times 3 times 3. No, yeah, 2 to the 4 times 3, sorry. Now, how do we use this, use the index rule? Well, stating by this rule, we can use this in reverse. Say n was a half. What does this mean? Half means a radical. This means this is the same as this. Okay, technically, but for this case it is. Using this fact, we can break this down into 2 squared times square root of 3 times square root of 5 squared. Now, what does the half square root mean? A half. 2 times a half is equals to 1. So these powers get divided by a half. The 3 remains root 3 because this cannot be simplified further. Root 3 is equals to 3 to the half and blah blah blah. It cannot do that. 2 times 5 can be simplified to 10. And so this entire thing becomes 10 root 3. Following, this is 2 to the 4 root 3. Now this can become 2 squared or 4 because this is even. 4 times a half is equals to 2. 2 squared is equals to 4 and blah blah blah. Nice. And finally we add them together. This becomes 14 root 3. And that is our answer, 14 root 3. Another example where we would use this. Here we have 3 squared and 2 squared 3. Here you can do this trivial this is trivial. This, however, what do we do this? Recall that multiplication of a index of 2 numbers with the same base means we add the powers. Okay. These are some cute A's I made. So following this, we can remove a term from this. This becomes 3 times 3 squared. Okay, so we make the power n even until you can put this outside, and we can then finally complete this to be 5. Very simple. Next, subtraction also very easy. So we get here 5 cubed minus root 2 squared times 5. Now I'm doing this instantly. You guys can take your time. You guys can do prime factorization. I do not care. Okay, it is to keep the video moving. This becomes 5 root 5. 5 minus 2 is 3 root 5, like so. A few more and then we will continue on with our work. This becomes 5 root 3 minus 3 root 3, which becomes 2 root 3. Another one. Okay, these are from 0607. Now I've used many syllabuses in this. Many? What do I mean by many? Only one syllabus. Yes, only 3 syllabuses. So yeah, here let's stop. Okay, 147. What can this be simplified to? 1 plus 4, 5, 7, 12. So this is divisible by 3. 1, 4, 7, 3. We get this is a 12. So this is 4. This is 27. So this is 9 and 7, 7, 1. So this is 7 squared root 7 root 3. Sorry. And this becomes 10 root 3. Following this, let's do multiplication. How do we do multiplication with surds? Well, they are simple. We use the FOIL method. Okay, FOIL method. So FOIL method is that you learn in algebra. First, inside, so this is negative 5. Outside, okay, so this is minus 6 root 5, and last plus 3 times 3 root 5 squared. Now root 5 squared cancels out to make 5, and carefully multiplying we get 15. 2 plus 15 is 17. Negative 1 negative 6 is equal to negative 7. So this evaluates to 17 negative 17 minus 7 root 5. 1. Let's do another one. First, so this is 6 times 6 root 2 squared. This cancels out. 6 times 2 is 12. First, outside, inside, and last. 12 minus 2 is 10. 3 minus 4 is negative 1. So this evaluates to 10 negative 2. Here we can find the values of a and b by cross multiplying on both. No. This is later. Here this is also something we can do. This is the same as 5 plus 5 squared plus 2 times 5 times root 3 plus root 3 squared. This becomes 3, this becomes 25, this becomes 8. 2 times 5 is 10, this is 10 root 3. I hope you guys understand how you can do this very easily with yourself. Okay, by yourself. You can also use the distributive property instead. So this will become 4 root 12 times 3 minus 7 times 3 times 3. 12 times 3, what does it become? Well, it becomes 36. 36 is 4 times 6. 3 times 3 is 9. 9 is 3. So this becomes 12. This becomes 1. So this evaluates to negative 9. Very simple. Following. Now, how do we divide by a surd? How do we do this? Well, this comes in two ways. I have explained it in both ways in my notes. If we have the form a over root b, how do you fix this? It says to rationalize the denominator, and this is the technique we do use everywhere. Let me give you an example first before knowing why do we need to do this. Before doing this, you need to know why do we do this. Okay, here's the analogy. Say you want to divide a number by 2. This is trivial. You know that your two tables, you can subtract by 2 and easy. By 3, simple. By 5, no problem. 6, easy. 7, a bit tricky, but you can get the job done, or hopefully. 11, quite easy, and other primes and composites. Now, what if I told you to divide by irrational? This repeats forever, and you cannot remember infinite digits. So what do we do? How do you fix it? We make it something that we do remember. We remove the third together. How? We multiply this by itself so that we use the property of the square. What does the square mean? Meaning repeated multiplication twice. So this is square root 2. This removes the 2, and we can safely compute this number. Now division of 2, this is trivial now. This is 0.707 blah 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 blah, and the same thing as 1/2. This is a bit trickier, but this you can do it possibly, but this is infinitely better to do, because you know how to divide by 2, and the irrational is repeating, and you do not care how long the thing is, if you can just divide by easy number. So this is the same line of reasoning why we always try to rationalize the denominator. Let's do this on here as well. We multiply root 10 on both sides. On the denominator, we get 10 because root squared is cancels out. So this is that. This is root 10. 6 and 10 can be simplified to 3 or 5, and that is your final answer. Following here, root 5, this is 10 root 5 all over 5. This simplifies to 2, so this is 2 root 5. Nice. There's also these 1 marker questions. You can do this trivially now that I told you. Root 7 over, here it would be 6 root 3 over 3, which becomes 2 root 12 root 2 all over 2, which is 6 root 2, and so on. I think you guys get it. Now, for when the denominator is not a simple surd. What about when it is a number like such, in the form a plus root b? Well, we use the same reasoning, but use a different formula. Which funny? What do we multiply by to remove this? Let's see. What if we multiply by the same thing? This gives us not a good value. This gives us 4 root 7 plus 7. We still have the root 7. We do not want this middle term where we have the a and the b. We do not want this middle term. We want b squared and a squared only and only. We know a identity which does this. A plus b, a minus b is equal to a squared minus b squared. There is no ab term here. It is only the squares. And if you plug this in, so we get 2 squared plus minus root 7 squared. This is root 7, this is 4, this leaves us with negative 3. Using this, we can apply this property like so. In my notes, I said we apply the conjugate. Okay, now this little word, this conjugate word, you will hear in A-level mathematics or AS, I don't know, complex numbers. But here we can use the same thing, where we flip the sign of the surd. Yes, the coefficient of the surd, we flip its sign. That's what the coefficient means. So multiplying by the coefficient of this on both sides, of course, we get 18 minus 9 root 7 all over what? So this is 2 squared minus root 7 squared. This is minus 7. 4. This is negative 3. So this evaluates to 3 root 7 minus 6. Very easy. 3. Oh my god. Root 7 minus 6. You get it, right? Let's do a bit more questions, and so that we are comfortable with division by this new method. So we apply the conjugate. We negate this 3 plus root 5. So you get 3 squared minus root 5 squared this is root 5, this is 9, 9 minus 5 is 4, so we get 3 plus root 5 all over 4, very easy. Here we get 4 squared minus root 6 squared, root cancel, 4 squared is 6, 16, 16 minus 10 is 10, 20, and we normally have multiplied by the conjugate up here, so this will become 10. It's like really hot in here, that's why I have the fan on. Okay, normally I do not have the fan on just so that you guys can hear my voice, but what can you do when you literally cannot do something against the heat? Okay, here I instantly did this, I think you guys get the point. Okay, you guys get the point. Let's do some interesting questions that we can find here. Okay, using our knowledge that we just gained. Okay, 40 root 8, 5 root 2 is equals to k, where k is an integer. Find k. This evaluates to an integer. How do we know this is an integer? Well, this root 8 can be simplified to 2 root 2 times 40 over 5 root 2. Root 2 cancel, and so we can see k is an integer. How? 5 and 40 cancel out. 40 is this becomes 6. 6. Oh my god. Not 16. 8. Yeah, 8. Sorry. So this becomes 16 is equals to k. Nice. Following 3 over root 2 plus 1 is equals to a root 2 plus b. Find the values of a and b. So ab, then this will be 3 root 2 minus 3. I just multiplied this, do not worry. And this will be 2 minus 1, because 2 squared is root 2 squared is root 2 and 1 squared is 1 obviously, so this is on 1. So this is a is 3, b is negative 3. This is a fun one. Why? Because we have the conjugate given to us, but we cannot take things for granted, in life. Not everything is for free. My notes may not be free. I hope not. Okay, but sometimes difficulty arises in 14. So you better like, subscribe, that you guys can keep supporting me, and I keep making videos for the future generation who will benefit from these videos. Now here we can simplify this further. Let me get my 7, 3, not my calculator, of course, this is all is from non-calc papers. Okay, you can see that I am not doing 40-24 questions because they are at the very bottom and they are not very interesting, unfortunately. Okay, 40-24 is not fun around. Okay, it does not like to challenge people. Okay, it does sometimes, but come on. This is also simple. Something. Ooh, yeah. These guys. The trio. Okay, these guys are repeated in this thingy. Okay, this is fun. We use the first thingy like so. So this is 75. So this is 5 root 3 minus 2 root 3 plus 3 root 3. So you guys can kind of see the pattern. When you solve for 1, you know this next third, what will it be? So 5 minus 2 is 3 minus 3 plus 3 is 6, so 6 root 3. We can simplify this to be 5 root 2. So here we can possibly find root 2, which is 2 to the 4 root 2 to the 4, so this is 4 root 2 minus 6 root 2. Okay, you can do this slowly. Okay, do not worry. It's negative 2 plus 5, it is 3 root 2. Okay. Simplify. Okay, sometimes it will be like immediate straight up face value. Do this, please. This same meaning you do your shenanigans. Okay, so let's simplify this. 92 divisible by 8, so this is 45. 4, 49, 7, 7, 1, so this is 7 root 2. Very easy. I'm not doing rationalized denominator, it's kind of boring, you know. P and Q. So square this, we get 2 root 3 squared minus plus 2. Okay, I'm not gonna do some goofy magic. This syllabus is already hard enough, come on. 2 to 3, so this is 4 times 3 minus 2 to 4, 4, 3, 12 times 3 times. Now here we have root 3 root 2. So this will actually be root 6 because 3 times 2 is 6, and I said before bn is equal to ab all to the n, and we have 9 times 2. Simplify. 12, 18, 30. Nice. Okay, here's a bit fun one. Expand the brackets. Okay, expanding, you get a squared minus b squared. We remove the squares. Okay, it's like it kind of defeats the purpose, you know. Work out the value of. Now this looks a bit scary. It's not. It is, but it's not. Okay, it actually is not, because u is the u or is u. We can quickly do the denominator bit. Okay, on a numerator, everyone will have the conjugates. 9 root 9 minus root 8, root 8 minus root 7, root 7 minus root 6, root 6 minus root 5, root 5 minus root 4. I know I'm getting out of space. On the denominator, we will use this property where we remove the squares. So this is 9 minus 8, 8 minus 7, 7 minus 6, 6 minus, you guys get the point. Everyone removes their denominator in the squares. And what are they left with? 1, 1, 1, 1, 1. So every 1 is 1. And 1 is what? 1 is 1. 1 over 1 is 1. So we have 1 here. Then the negatives and the positives cancel out. Cancel, 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 cancel culture. And we are left with what? Negative 9, root 9 minus root 4 is 3 minus 2, all is equals to 1. Yes, all that crap, that's for 2. You are given that, and each character 2 decimal places. Use this information to find a value of. We can simplify this. This is 10 root 7. 10 root 7, so this is 10 times 2.65, which is equals to 26, around 26.5. Remember, we won't, we will only use this information. We do not have to kill ourselves over this is not two decimal places still, but we come on. This is 4 root 70. 70 is equals to 8.37, and multiply this by 4. We get 32.3 is 12, and 7 is 28. 8433 33.48. I guess you guys have done all of these. I hope so. Okay. By the end of this, the worksheet is in the description. I hope you guys like this video. Okay, informative and such and such and such. I will, get going, prepare for the next session. I hope you guys, I have had a great session. Okay, this time. Okay, if it's not good because of the leaks and stuff and the all scamming, the diapers having a better leak protection than Cambridge, then I wish that you guys have at least the best, a good score that you guys might be favorable to. Okay, I remember someone was trying to aim for a D. How we all were trying to get him to, like, no, do not get a D. Why are you doing this? A D is a bad grade. Like, bro, do not get a D. And we all tried our best to console him. At the end, I hope he had gotten some confidence. I hope. But other than that, yeah, I never saw him because I got banned. But in the time I was on the server /IGCSE, I didn't quite see him often. Bye.